Hello everyone, welcome back to my YouTube channel. Myself Monisha V, studying in Sri Venkateshwara College of Engineering from the Department of Information Science Engineering. My topic for today is file structure. In that topic, we have multi-level indexing B-tree. The contents for today's topics are indexing, multi-level index, types of multi-level indexes, B-tree, B plus tree, and conclusion. Indexing. Indexing helps to optimize the performance of a database. It minimizes the number of disk accesses required when a query is processed. It is a data structure technique which is used to quickly locate and access the data in a database. There are two things used in indexing. These are search key or candidate key and data reference or pointer. The structure of single index, as you can see in the above diagram, there are search key and the data references, where search key will give the key and the data references will give the value. Multi-level indexes. Multi-level index refer to hierarchical structure of index. Here, each level of the index provides a more detailed reference to the data. It allows faster data retrieval, reduces disk access, and improves query performance. Multi-level indexes are essential in large databases where traditional index are not efficient. A multi-level index can be created for any first-level index, primary, secondary, or clustering. It has more than one disk block. It's like a search tree, but adding or removing new index entries is challenging because every level of the index is an ordered file. Types of multi-level index. There are two main types of multi-level indexes, B-tree index and B plus tree index. These are explained as follows below in the brief. B-tree index, this type of index is used in most database management systems. It's balanced tree data structure in which each node in the tree contains a set of keys and pointers to its child node. B minus tree are highly efficient for range queries and support insertion and deletion of the records without requiring a complete restructuring of the index. As you can see in the left side, these are the multi-level indexing. It consists of outer blocks, inner blocks, and data blocks. To solve this problem, most multi-level indexes use B minus tree and B plus tree data structures. These structures leave some space in each tree node to allow for new index entries. A multi-level index treats the index file like an ordered file with a unique entry for each k. B minus tree advantages. These are highly efficient for range queries as they allow for quick traversal of the tree structure. These are balanced and therefore provide predictable search and retrieval times. This can handle a large number of inserts and deletes efficiently without requiring a complete recognition of the index. This works well for both the primary index and the secondary index. B minus tree disadvantages are these have a higher overhead than other index types, which can become a problem for very large database. This can be a complex to implement and manage. This may not be as efficient for point queries as they are for range queries. B plus tree index. This type of index is similar to B minus tree but with some modification to improve the performance of range queries. In a B plus tree, only the leaf nodes contain actual data records, while the non-leaf node acts as a key for the child nodes. B plus tree are often used for large databases with high read operations and write operations as they can handle large amounts of data with relatively lower overhead. B plus tree advantages. These are optimized for range queries and are therefore faster for queries that require range searches. These have a lower overhead than B tree, which makes them more efficient for large databases. These perform well for secondary index as they store the data only in leaf node. These have a simpler implementation than B trees. B plus tree disadvantages are this require more disk access than B minus tree for point queries which can impact performance. This required more overhead for inserts and deletes than B minus tree. This can be more complex to implement and manage than other index types. Comparison of B minus tree and B plus tree indexing methods are. This table provides a general comparison, but specific advantages and disadvantages may depend on the particular use case and database system. As you can see, these are the comparison between the B minus tree and B plus tree. The data storage, both internal and leaf node store key value pairs in the B minus tree. In B plus tree, only leaf node store key value pairs. Fan out, lower fan out due to internal node storing data in B minus tree. Higher fan out due to internal nodes only storing keys in B plus tree. Range queries requires additional disk access to retrieve data from internal nodes. Can perform range queries more efficiently by only accessing leaf nodes. Insertion or deletion requires more overhead due to internal nodes storing data, requires less overhead due to internal nodes only storing keys in B plus tree. Insert, Inserting a data entry into a B plus tree. Summary. Find correct leaf L. Put data entry onto L. If L has enough space, done, else must split L into L and a new node L2. Redistribute entries evenly. Put middle key in L2. Copy up middle key. Insert the index entry pointing to L2 into parent of L. This can happen recursively to split index node. Redistribute entries evenly but push up middle key. Splits tree. Root split increases height. Regrowth gets wider or one level taller at top. Conclusion for today's topic. Tree structure index are ideal for range searches, also good for equality search. B plus tree is a dynamic structure. Insert delete leaves. Tree height balanced. I fan out of F means depth rarely more than 3 or 4. Almost always better than maintaining a sorted file. Typically 67% occupancy on average. If data entries are data records, splits can change rights. Most widely used index in database management system because of its versatility, one of the most optimized components of a DBMS. Thank you.